All right, so quick reminder that on Schoology, some of you got little messages, so make sure you check in your comments because the assignment required graphing. And if you didn't do the graphing, I have to see the graph paper, so you probably have it somewhere. You just need to take a picture of it. And then you can resubmit it. And I can give you credit for it because when we take the test, that's the cutoff for all assignments. And to be eligible for the retakes, you have to have everything in. So make sure you're checking those comments. And I just gave you the note packets and the practice test. And then after we finish this up, I will give you the review assignment. And I'll make sure I put it up here for the folks that are doing distance learning today too. Alrighty. So, as I mentioned before, this is just like the test, but with different numbers. So if you can do this today and study it over the next couple of days, you should ace this little bugger of a test that we're going to be taking. Write an equation that translates the parent function y equals x squared to the left 3 units and down 4 units. So this was back in section 2.6. And we have to pay attention to the fact that this is not absolute value. This is the quantity x minus h squared plus k. Because this is a parabola. This is not a v. This is a parabola. And it says we're going to take the original and we're going to move it left 3 and down 4. Well, that has nothing to do with A. A is about slope. That has to do with H and K. So if we're supposed to move it left 3, what do I really have to put in here for H? Yeah, it's going to be an x plus 3. How do I make sure it goes 4 units down? Minus 4 in the back. And I don't have to do anything with A because it didn't say it was a vertical stretch, vertical compression, anything like that. So it will be y equals the quantity x plus 3 squared minus 4. That one's done. Number 2. Now we're describing the transformation. This time, notice the parent function. That's going to be huge. The parent function is absolute value. And now we have y equals 6, absolute value of x plus 5, and then a plus 7. Write your little y equals a, absolute value of x minus h plus k right below it. That'll help so you don't mess up. And then go left to right and describe what these numbers are doing. What's this 6 doing? Factor of 6. I write too big. I probably won't have enough lines for mine. So that's the first number that we see that's not y equals the absolute value of x. Every number has to be explained. So I keep going and I see plus 5. What does that mean? X plus 5. Translate left 5 units. Am I done or should I put an and? I need an and. Got another number to deal with, don't we? And what's the plus 7 in the back saying? 7 up. 7 units up. I'm going to have to write that down here because I write too big. So now let's make sure we took care of all 3 of those numbers. Vertical stretch, factor of 6. That's one of them. Translate left 5 units. Second one. And 7 units up. Third one. We've got them all. Now let's just say that maybe on the test this were a -6. What would you have to say to start off if this were a -6 on the test? You're missing something important here, everybody that's going on to the next problem. If on the test it has this, what do we have to write down first? We've totally forgotten. Reflected over the x-axis. So if there's a negative, you have to do that reflection over the x-axis. So that's just a what if in a couple of days. Alrighty, number 3. Find the function g of x that represents the reflection of f of x equals -5x plus 8 over the x-axis. Oh, well, f of x is just y. So if I want to reflect over the x-axis, what do I have to make negative? Yep, Lily's got it. You make the y negative. Do you suppose we leave it that way? It looks wrong, doesn't it? Yeah. So we would divide everything or multiply everything by -1. And that would be our answer. But did they say we could name it y? So we'd miss like a quarter of a point if we didn't catch this. It said we have to name it g of x. So g of x equals 5x minus 8. Now some people do a really great thing when they're reading a problem like this. They say find the function. Oh, I'm going to forget that. Let me underline that right now so I don't forget that little g of x thing. You know, like I said, quarter or half a point or something. It's not a lot, but hey, you should be able to get a perfect score on this one. So why not make sure of it, right? So as you read through it, underline important stuff that you think, gosh, I might forget this. Graph the function. Clearly mark at least 3 points on the graph. Identify the vertex and the axis of symmetry. Well, of course we will. We want those things. So I see that it's absolute value. And I put my little formula down there. And if we're going to graph, what should we find first? Yeah, the vertex. So be careful. Somebody always does this one backwards. What would the vertex be? Got a test in 2 days. What would the vertex be? 2, -1. Good. X's are always opposite. So there's our vertex. 2, -1. I might as well write that down in the blank as long as I'm over there, huh? Now this part we may have forgotten because it's been a little while since we did this. Axis of symmetry. Well, let's see. It always goes right through the vertex, and I realize I'm karate chopping the x-axis. X equals something. What's x going to equal? Remember, don't overthink this. What does x equal? 2. Because it goes through the vertex. So x equals 2. I don't have a v yet. How am I going to get a v? There's a number up there we haven't used yet. What is it? 3. So that's the slope of the right side of the graph. So we go back to our vertex and we go up 3 and right 1. I'm going to do that a couple of times. So how do I get the other side of the v? Up 3, left 1. Now this one is not an inequality, so this is going to be solid. This is an equals. So with equals, we just draw in that lovely V. So let me tell you what people accidentally do on this one. They accidentally draw a straight line. That is such a bummer, because it's like they're just missing the other side of the V. And then they try to do the dashed and solid stuff, but this is not an inequality. This is an equation, so it's just a V. That's all it is. All right, now the directions change, and it says graph each inequality. So now I have to push the pause button for part of this. All right, that is not y equals mx plus b. That's standard form. So I pretend it says 4x plus 2y equals negative 8. And I find the zeros. It's the easiest way to do these. So if there's a 0 for x, this is gone, and it's going to say 2 times something is negative 8. What would the something be? Negative 4. Well, I know 2 people that are going to do well on this test. The rest of you need to speak. How about if y is 0? 4 times something is negative 8. What's the something? Negative 2. There's our 2 starter points right there. 0, 1, 2, 3, 4 down, and negative 2, 0. Pause button. Dashed or solid? Dashed. It does not have an equals bar. Oh boy, I wish I had more to aim for here. Done? No? What's left? Maybe it is done. What haven't we done yet? We haven't shaded. How do we know where to shade? We're all using the stare at it and hope it goes away method right now. That's not going to help. It's still there. It's not disappearing. How do we know where to shade? This has me worried. Some people have not been watching the videos. We test a point. What's a nice, easy point to test? 0, 0. Yeah, since it doesn't go through 0, 0, let's take the easy road. Let's test 0, 0. So now it's going to say 4 times 0 plus 2 times 0 is less than negative 8. Well, that's 0 plus 0, which is 0. Hey, wait a second. Is 0 less than negative 8? No, it's not. So I can't shade where 0, 0 is. I have to shade on the other side. But this is a test. And like I told you, on the videos or in class, I would check a point on the other side also and make sure that it does not work. Well, actually that it does work in this case because we already know 0, 0 doesn't work. So maybe I'll try negative 5, 0. Because that's in the green. That's where it's supposed to be. So this would say 4 times negative 5 plus 2 times 0 is less than negative 8. Negative 20 is less than negative 8. Is negative 20 to the left of negative 8 on the number line? Then I know I'm right. I shaded in the right spot. Because I already found out 0, 0 doesn't work over here, and now I just found out, yes, the spot that I have shaded works. Alrighty, let's look at 6. Is 6 a line? No, that's an absolute value. This is a V. Now, we already did one of these, so I know you can help me out more on this one. So when we want to graph the V, where do we start? The vertex, yeah. So where would the vertex be? Josh, you want to give the... Oh! Riley, was that you? Oh, careful. 1 is right, because it's with the x. But the k in the back, you just take exactly what you see. So you have to remember x is opposites, but the one in the back is normal. So 1, 3. Oh my goodness, I can hardly see my little lines. Try there. What do we use next to help us make a v? Marcos? -3? Use that as your slope. So down 3 and right 1, and even though I can barely see these little thingies, I'm going to try. Not a V yet. Oh, I'm sorry, I didn't look. You're right. Down 2 and right 1. I can't see these things. Are yours better on your paper copy, or are they faded on there too? Okay, slope of the right side, -2. Now I need the other side of the V. How do you get it? So down 2 and left 1. Pause button. Dashed or solid? This one's solid. It has an equals bar. Now, I don't think it actually goes through 0, 0. I think I'm a little off. But this was good that this happened. Because if on the test you're not sure, whether or not it really goes in there or not, then pick something else that would be easy to do. Like with this one, maybe I'll pick 0, -5 and see if it works. Because on the test you might have one where your V or your line goes right through 0, 0. So let's put that back in the original. It's going to say -5 is greater than or equal to -2 times the absolute value of 0 minus 1 plus 3. So we just have to follow the order of operations here, and we'll be able to see whether or not we should shade inside. 0 minus 1 is -1. What's the absolute value of -1? 1. What's -2 times 1? -2. What's -2 plus 3? Is -5 greater than or equal to 1? No. So I can't shade inside my V. I have to shade outside. And like I said, it's a test. You're going to have a ton of time. There's all kinds of points here that are shaded, so maybe I'll try 0, 5. Oh, I don't want to use the same color I did for the last test, or last problem here. Because right now I'm saying that should be shaded, so that should work. And that would be 5 is greater than or equal to -2 times the absolute value of 0 minus 1 plus 3. Well, we already did the math for a 0 on the right-hand side. That came out to 1. Hey, we shaded in the right spot, because that's the spot that works. Up there. So far, so good? All right. Write an inequality that represents the graph below. That's a line. But it has the shading. So it's going to be y something, and the easiest if we could get mx plus b. So let's see if we can do that. Is this crossing the y-axis in a nice spot? It is. Right down here at -2. So that means b is -2. Now, if you're having trouble, we've talked about this before with the visual thing with slope, you could always say, oh, it goes through this one, and it goes through this one, And then use slope, slope, find the slope, average rate of change. y2 minus y1 over x2 minus x1. You get the same thing. But hopefully you're saying, so I would have to go down 2 and right 3. Again, that's exactly what you would get, change in y over change in x. All done already. Great. Thank you. So we've got the slope and we've got b. Y something 2/3 x minus 2. Did they shade up or did they shade down? Up. So we could use the shortcut and say we're pretty sure it's going to be greater than. Should we put an equals bar there? Nope. But again, it is better if you test a point and make things true here. So I would definitely do 0, 0. 0, 0 is supposed to work. It's in the shaded region. So 0 something 2/3 times 0 minus 2. That's going to say 0 something negative 2. How do we make that true? It's greater than, isn't it? So that's what we had. And this would be y is greater than 2/3 x minus 2. Got it. Now, if you're saying, see, Jerome, I did that a different way. I took these 2 points, I found the slope, and then I put it into point-slope form, and I got exactly the same thing when I put it into slope-intercept. Yep, you will. So there are different ways to do this one. As long as you can get there, that's all we care about. All right, this one says, graph each equation, and it's just y equals x. Interesting. That does look a little bit like y equals mx plus b, right? But there's no b value. What does that mean it was? Yeah, it was 0. And if it just says x, what was the slope? 1. So up 1 and over 1, up 1 and right 1. And then I'll use the slope backwards. Hey, look at that. This is the perfect diagonal through first and third quadrant. Yeah, that's what the line y equals x does. It's the perfect diagonal through quadrant 1 and quadrant 3. Number 9. Oh, that looks like a trick question. X equals negative 3. Well, we'd have to karate chop the x-axis. What kind of line does that make this? Remember the fancy name? It's a fancy name for the lines that go this way. Vertical. 1, 2, 3. There it is. Now, y equals x, another way to do that one would be to make a little table and say, well, they're always equal. This is kind of a silly table. End up with the exact same line that we had there. With 9, you have to know, oh, it's missing the y. Well, that means it's karate chopping the x-axis at negative 3. And that karate chop shows you that this is going to be a vertical line. If it says y equals 4, then you have to karate chop the y-axis. And that lets you know that it's going to be a horizontal line when you do that one. And we are done. Because we tested you on this one for the first test. This was 2, 5. So that's the test right there with different numbers. That's it. So I'm going to put the assignment up here for the people that are doing the distance learning thing. And then I'm going to bring you your own little sheet of paper with the review assignment on there. So let me see. Whenever I move this thing, everything gets moved around. Algebra 2 review assignment. I need something with 2, 6, 7, and 8. Well, I'm going to stop the recording. All right, so here's the review, but this is the problem that you were already tested on from section 2.5, so you don't need to do that. There's the review assignment.